right, so I am told that your problem areas are multivariate calculus and also um, multivariate calculus and integration, right? No, I was hoping to get both of them done in the one session that we have planned for today. But if I rushed through it to get both of them done, then I'm pretty sure the session would be productive. So I've made the decision to focus on integration for now, and then possibly we could hopefully figure out something else, and then we can do another session with multivariate calculus. So my approach for it is that I'm going to be basically taking questions from your problem sets. I was afforded the problem sets. So I'm going to be taking questions from your problem sets, and what I'll do is I will explain them and also tell you how you can approach them, right? So we're looking at integration, and you guys would have known by now that integration is a whole headache. I'll tell you that I have to teach it from time to time, and I don't really enjoy teaching it because it gives you quite a headache when you're trying to help students understand the whole essence of it. So you know that calculus has two different branches. Two branches of calculus are differential calculus and integral calculus. Differentiation is way easier than differentiation. Differentiation is way easier than integration because differentiation will be very straightforward. It tells you the rules as is, and the rules never change. Integration, we tell you a rule today, then when you come back tomorrow, then it's updated to something new. It's a bag of stuff you have to know, right? Once you get it, you get it. So what I'd like to do is start by defining integration. What I'd like to do is start by defining integration, right? Mathematically, we define integration as the reverse process of differentiation.
All right then.
So when we talk about integration, basically what we're doing is try to reverse whatever we would normally do in the sense of differentiation.
That's a record. Yeah.
Could you mute the microphone, please? Thank you so much. All right. So basically, it's the reverse process of differentiation, right? Now, what we look at is the two types of integration that we're going to look at. So the types of integration that you look at are going to be what we call a definite integral and also what we call an indefinite integral. So we have a definite integral and an indefinite integral. So definite and indefinite. Now, what's the difference between the two of them, right? Definite integral will produce what we call a summative function because the definite integral will give you the sum of some kind of values. So in some sense, in the one-dimensional space, it gives you the area under a curve. In a two-dimensional space, it gives you the volume of it gives you some kind of stuff, right? So it's a summative function that we're going to be looking at. It basically sums up some values and give you, right? The indefinite function, the indefinite integral gives us what we call a family of integral curves. And I'll demonstrate what we call integral curves by giving an example. So everybody's supposed to know how to integrate already, right? So if I ask you how to integrate something as simple as, say, 2x dx, right? When I integrate this, I'm going to raise the power of x. The power here is 1. Whenever there's no value, it's always 1. So I'm going to raise that power by 1. So it's going to give me x to the 1 plus 1, right? And there's a 2 at front. And I'm going to divide by the new power, which is 1 plus 1. We realize this is 2x squared, or don't forget a plus c, right? 2x squared over 2 plus c. What's going to happen here? It is x squared plus c. Now, what do we mean by a family of integral curves? We get a family of curves because it depends on the value of c. So what I'll do is drop a quick diagram here. So this curve here is x squared, and this is when c is equal to 0. This curve here is when c is equal to 1, so the value passes through 1 here, when c equal 1. And you realize that the value of c will give you different curves, so this is when c equal 2, and it passes through 2 and so forth. So all the collection of values that we have, all the collection of values will be what we call an indefinite integral. So just an introduction to integration. You guys are not seeing anything? All right, let me try to fix that share screen. Are you seeing it now? Is everyone seeing the share screen now? All right. Cool, no problem, man. All right. So this is just an introduction to it all, right? Now, before we actually talk about how we're going to integrate and all the stuff, we need to know some basics integral rules, right? Because the basics are going to come up a lot. So the basic integral rules that you guys need to know are basically some of the results. So the integral rules here, right? So the integral of e to the x, dx, is always just going to give you e to the x, right? So when you integrate e to the x, you get by the same thing. The integral of 1 over x dx, integral of 1 over x dx is actually going to be equal to ln mod x plus c. The mod here is very important because without it, then you haven't restricted the domain. So it's very important that you do that, all right? The integral of sine x, we're going to be using some of these for today, is going to be equal to negative cosine x plus c, and then the integral of cosine x dx is going to be equal to sine x plus c, and then we all know that the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. So these are some integral rules that you're expected to know, the others that you can derive. So what we're going to be doing now, we're going to start with some basic integrals, and I call them basic because they're very easy, but they demonstrate how you can actually integrate. All right, so basic integrals, and we're going to start with indefinites first. For the first example, we're going to look at the first example here being the integral of 2x squared plus x plus 1 over x squared dx. All right. Shika, I am not so sure how you can record, but what I'll do, I will send this document to Kymani so he could then distribute it afterwards. All right. But the session is currently being recorded by Kymani, so as well you could ask him at the end of the session for a link to the video. All right. So let's go back to this. So how do I do this basic integral? And I'm calling it basic because it doesn't require any extravagant rule. How we integrate this is to write all the values or all the x terms as an exponent, right? So you realize that this is 2x squared, this is x, and this is 1 over x squared. So I'm going to rewrite the 1 over x squared. So 2x squared, I have it as a power, x there to the 1. What I'm going to do, I'm going to change this to a power. So I'm going to bring it to the numerator, and this will give me x to the minus 2. Now the trick here is once you're carrying it up to the numerator, you just simply change the power to a negative value. All right, so always remember that trick. All right, so let's integrate now by using this law here, right? So when I integrate 2x squared, I'm going to raise the power by 1, which gives me 3. So x cubed there, and I have 2 up top. Then I'm going to divide by the new power, which is 3. So that gives me that there. Same thing here, raise the power by 1, that gives me squared. Divide by the new power over 2. Now raise x to the minus 2, so I have x to the minus 2. I'm going to add 1 to minus 2. I get a minus 1, right? And I'm going to divide by the negative 1 here. Then don't forget to write a plus c. Now we aren't finished because we need to simplify. Ready? So normally what I do is write the numbers at the front. So 2 over 3 x cubed. Then I'm going to have plus a half x squared. Now, because we have a negative here, so meant it. So this is a positive x to the minus 1 divided by a negative 1. Positive divided by negative gives you an overall negative, so I put that there, right? Now, this is over 1, so it just gives you x to the minus 1. Now, when we have something as a negative 4, what we can do is write it as 1 over just it raised to the positive 4. So what I'll have now is 1 over x plus c. And that is the most basic form of integration that you could get. So you're simply applying the power rule here, raise the power by 1, divide by the new power. And that's just a starter for what we're going to be doing for the day. So I don't want to be moving too fast, but I also don't want to be moving too slow because we won't get much done. So that's your very, very first example, right? Well, let's look at another example here. And it's going to be using some other rules, but you have to reduce it, right? So here we're looking at the integral of u cubed plus u squared minus u plus 1 all over u squared du. Now you realize that the first example talked about x, this example is talking about u. You have to pay attention to what we're differentiating with respect to. So this means not differentiating, integrating. So this means that we're integrating this expression here with respect to u. Now, let me just say that at the moment you haven't been exposed to any like integral properties for products and quotients or anything like that. You have that for differentiation, not at the moment yet. So an easy way to do this is to actually break this down into simple fractions, right? So when I break this down into simple fractions now, it's going to give me u cubed over u squared. So what I'm going to do, I'm just going to break it up already, plus u squared over u squared minus u over u squared, then plus 1 over u squared du, right? Now, what we're going to do, let me just come down here now. What we're going to do, we're going to simplify this expression. So when I have u cubed over u squared, what you normally do when you're dividing with the same base is you subtract the powers. So 3 minus 2 gives me 1, so I'm just going to be left with u to the 1 there. Cool. Then I have u squared divided by u squared. They both cancel each other out, so I get 1 there overall. Then I have minus u over u squared. Now this is 1, right? So let me just put the minus at the front from the get-go. So this is 1 u to the 1 over u squared. So 1 minus 2 is going to give me a minus 1. So u to the minus 1 here now. Write my sign, which is a plus. So when I do that now, I'm going to get, so this here is nothing there. So remember that property that I just showed you where you're just moving the exponents from top to bottom. So once I move it from bottom, the denominator to the numerator, all I do is just change the sign of the power. So that's u to the minus 2 there. And then I have du. Now what we can do is actually use our integral properties, right? But before I do that, I'd like to rewrite this in a specific format so that you guys can pick up the integral rule. So 1 over u. I'm doing this because I want you guys to pick up the integral. Ready? So when I integrate each of these individually, I'm going to get that u, when I integrate u to the 1, raise the power by 1, so that gives me u squared, divided by the new power, which is 2. This is 1x to the 0. When I integrate a constant, I just get the constant times the variable, which is u now, minus, when I integrate 1 over u, if you remember this result up here, when you integrate 1 over anything, it always gives you ln of it. So what's going to happen here is that this is going to give me ln modulus of u. If you leave out the modulus, then you left off a mark. So it's very important that you include the modulus here. All right. Now, simply again with this one, when so I write my plus sign here. When I integrate u to the minus 2, what's going to happen is add 1 to minus 2, I get minus 1. So I have u to the minus 1 here now. Then I'm going to do what? I'm going to divide by the new power, which is minus 1. Then don't forget your plus c. Simplifying the entire thing now, it is u squared over 2 plus u minus ln mod u. Again, if you left off the mod, you left off your mark. I can't stress it anymore. If you leave off the mod, guys, you left off your mark. All right? So as we demonstrated up here, positive divided by negative will give you an overall negative. Then it's u to the minus 1. So remember, when you have a negative in the exponent, you drop it in the denominator and the exponent becomes positive. So it's 1 over u there, plus c, and that will be the entire integral. All right, so at this moment, I'll pause. Is there anything that you'd like me to explain?